2. So as you can see, I kind of analyze some of the important part. They give you gram of petroleum, they give you gram of carbon dioxide, they give you gram of water. And like the previous question, this question is much more easier because they said it doesn't have oxygen. So you know your hydrocarbon, which is petroleum in this case, doesn't have oxygen. So for the question number 2, right, the way we're gonna solve this is, first I want to write down the equation, CH, again we don't know X and Y, right? They didn't require this part, but I'm just doing it for practice. Okay, so what you're gonna do is you're gonna go ahead and convert this. 196 gram CO2. Unlike the earlier where we converted all the way to gram, we're gonna only convert it mole because we don't need to find the gram to figure out if there is an oxygen here. Okay, so time. If you know the molar mass of carbon dioxide, that would be helpful, but it is not required. If you do not know, simply you just figure out carbon molar mass and then add it 2 of the oxygen molar mass. So that would be 12.01 plus 16 times 2, or otherwise 44.01 gram CO2. That's gonna be 1 mole of CO2. Right, and then you know that it is 1 mole of CO2 is 1 mole of carbon. Once you get used to it, you will not need to figure out the molar mass, like I said. So let's go the same way. Water, 18.752 gram H2O. If you know the molar mass of water, that's great. Otherwise, you can still find out. It is 18.016 gram H2O, that's 1 mole. Now, 1 mole of H2O would have 2 mole of hydrogen. Okay, so you'll see grams go away, moles go away. You're gonna end up with hydrogen mole. Same here with the carbon. Okay, so you're gonna go ahead and calculate that. So if you did the calculation, let's see. Make sure you're entering correctly. I'm going to calculate about 3 decimal places. Now, can you get more decimal places? Yes, absolutely possible. So this is 8 mole C, same thing. It's gonna give me 0. Wait, I think I didn't enter that correctly. Yeah, I didn't enter that correctly. It's supposed to give you 2. So let me go back and try it. This should be about 2 because these two are about the same. This is gonna give me 2.082 mole of H. Okay, now unlike having to find the oxygen because they have no oxygen, you just go directly the ratio. Divided by the smaller ratio. That's what we want. You get about 2.399 about. Okay, so what you do is about 0.3, right? As opposed to 4. So we're just gonna multiply by 3. So that would be 3. That would be about 7.196. Again, we can say about 7. So C3H7. It would be our answer. Now, Let's go ahead and try to practice doing the equation. Let's see if we can balance it. Again, it's not required by the question, but we're trying balancing or the combustion reaction. So let's see what's happening. Okay, you will notice 3 carbons. I can do 3 carbon. That's 7. That's gonna make it a little bit troublesome here, which means I'm gonna multiply by 2, and then I'm gonna multiply by 7, which I believe is not gonna be troublesome for this guy because O will be 7. If you know ahead of time, you can go ahead and multiply the whole thing. If not, you can solve it first and then multiply everything by 2 to avoid the fraction that's going to happen here. Since I cannot see that, I'm just going to multiply by 4. Okay, so then that's going to become 14 here. Right? So 14 times 2, that's 28, right? Since this is 3 times 7, 3 times 4, 12. Now I'm going to look for O. That is 24. That's 14. Added together, 38. 38 divided by 2, that's going to give me 19. So 19O2 here. Okay, and then you can also check the COH, and then you will see that they are balanced.